This is a topic that is really hard for me to talk about um, because it hits very close to home in a number of ways. I've lost several family members to cancer, and most recently, I lost my dog to cancer, which was really difficult for me because, as I've tried to explain to people, she wasn't my pet. She wasn't like a family pet. Instead, she was trained to do basic jobs for me that I was unable to do for myself. And so, unlike a pet where you take them for walks and you play, I needed her to help me with things like getting the mail, walking up and down stairs, getting in and out of the shower. It's a very different dynamic whenever you rely on an animal versus having a pet. And so losing her was especially difficult. Um, so in any case, I'm going to talk briefly about diet and cancer, and I'm going to touch on the fact that there is a great deal of discussion about the ketogenic diet specifically and cancer, and I'm going to try to make these things more simple rather than boring people talking about, you know, um, all the technical terms that don't mean anything to the average person. It's really cool to use your vocabulary and talk over people's heads. It doesn't really communicate much besides the fact that you're too lazy to put it in normal terms. So anytime I use a term, I'm going to go ahead and I'm going to define it as well, or at least explain what it means, even if we aren't going to get into the acronym itself, because the acronym really doesn't matter, and moving forward. So first off, we have the Warburg Effect, and I'm sure you guys have probably heard this somewhere, that the whole thing could be a book in itself, but taken down on the most simple part, and the part that people want you to take away, is that basically cancer uses glucose. Um, that's partially true. It's partially true. Also have to keep in mind about lactate, which is a metabolite that happens. Um, it's You have these things like the Cori cycle and the Krebs cycle. You don't need to know all those steps. It's for really nerdy people who don't have anywhere to be on a Friday night. And basically, it's just another substrate that your body can use to produce energy, ATP. ATP is adenosine triphosphate, and that's what your body uses for energy. It goes through a cycle, becomes ADP when one of the phosphates break off, and then that ADP goes back through the cycle and picks up another phosphate, and now I basically think of it as being like reloaded or recharged. Okay, that's the easiest way to think of it, is that basically you use this little energy molecule, that part breaks off, and then it goes back through a cycle, gets recharged, and then you use it again. I know some science nerd out there is going to jump on me for describing it that way, but I think that that's the easiest way to describe it for people who really don't care about the steps of the Krebs cycle. So anyways, Warburg effect, it's not as simple as just simply moving glucose, because cancer is far more complex than that, and it can produce energy through a variety of other means. So although anaerobic glycolysis, where it ferments and produces energy, glycolysis being glycogen, so glucose, where it produces its energy through that process, that is not the only way that cancer can produce energy. That is a way. That is the way that many cancers do whenever their initial tumor forms. So when the tumor first starts to grow, it will utilize anaerobic glycolysis, which is using glucose. However, late-stage tumors, and especially tumors that have been treated with things like chemotherapy or radiation, will actually change their metabolic process to produce energy in a different way, which I'm going to get back to in just one moment here. The next thing I want to touch on is that a lot of this research focuses on animal models, and unfortunately, animal models are not perfect representations of human models. So the cell line, that's basically what it is. The type of cancer, the cell line that is used in an animal model doesn't always perfectly match a human model, human cell lines. Another thing I want to point out is be careful when you read the research. If it tells you that it increases survivability, that does not mean that they survived. I know that that doesn't make sense to a lot of people. You have to be very careful about the word choices in studies. So, if you get to the conclusion of an abstract and you see, oh, it increased the survivability by 50%, that might mean that the patients on the intervention died at 9 months instead of 6 months. Okay, so 100% of the patients still died. It's just that the one group lived 50% longer, so an extra 3 months past the other group. It doesn't mean that 50% of the people survived, which is what I think some people take that to mean. So if you see increased survivability by 50%, they're like, oh, see, 50% of the people survived. No, they just lived 50% longer. So be careful when you read research. I actually wasn't going to touch on that, but that just popped into my head because I mentioned the part about the animal models use cell lines that are not found in humans. So that's another thing you have to be careful about when you read research. Additionally, cancer changes in response to stressors and stimuli. So the thing is like if you took a cancer, you have a tumor, and you treat it with radiation, that radiation can actually cause that tumor to change its metabolic processes. So if it was at an early stage, it might be anaerobic glycolysis, and when you treat it with radiation, suddenly it switches to oxidative phosphorylation. If you introduce chemotherapy that increases reactive oxygen species, that's why you consume antioxidants, right? So you guys probably know, like, oh, blueberries are good for you because they have antioxidants. Well, what are antioxidants? Antioxidants work to reduce the oxidative stress. Pro-oxidants, I know. It's still kind of nerdy. I don't have a great way of explaining that in a super simple way, but basically the idea is that chemotherapy and radiation actually increase the stress on the cancer cell. That's how they kill cancer cells. And so whenever they put that stress on the cancer cell adapts and makes changes to itself, and it'll create endogenous antioxidants. I that's a real thing that actually is a phenomenon that we don't know how to stop that from happening. So, cancer can actually produce its own antioxidants to protect itself from the radiation and chemo drugs. It's incredible how cancer can adapt to practically everything. It just doesn't die. But that's another factor that you have to consider, is that if an intervention starts to work initially, it might not continue to work because cancer will adapt so readily. Okay, so getting around to the ketogenic diet, though, and pointing this out real quickly. Although the support for the ketogenic diet is relatively scarce, I don't want to act like there's a lot of research out there suggesting that it does work. Because, as I mentioned about the animal models, there's tons of animal models where it works, and it's like, well, that's not really useful to us in terms of humans. However, and I would like to point this out, there is some research. There actually is some research suggesting that ketogenic diets can be beneficial even in humans. And the catch to all this is that there basically really isn't any research whatsoever suggesting that a low-fat diet is beneficial. In fact, even when you look at the research, the higher your blood glucose level on average, the shorter you're going to survive with cancer, which is why people that are like type 2 diabetic or have insulin resistance have shorter survival times. So there certainly is some evidence suggesting that keeping your blood glucose down would be beneficial. So it's not like a high-carb, low-fat diet has evidence. It doesn't. It's just that the evidence for a ketogenic diet is relatively weak at this point, and that's really just a matter of the fact that there isn't enough research in any direction to say things definitively. And whenever you're dealing with people's lives, clinical researchers are very hesitant to recommend anything that isn't extremely well supported by the research. You're not going to take one study that showed, oh, hey, this kind of worked in this one study, and start applying that to patients. And that's good. That's a good thing. Like that. Don't take my comment to be a critical comment about clinical researchers. It's good that they err on the side of caution. We want that. So in any case, coming back around, like I mentioned, the ketogenic diet actually does have some evidence. Even from a mechanistic standpoint, it actually does have more evidence even on that regard. So there are HDAC inhibitors. HDAC inhibitors are, it's a histone deacetylase inhibitor, which doesn't mean anything to you. So that's a big fancy word. So I'm going to try to explain this in a different way. But basically, an HDAC inhibitor opens the chromatin, and I will explain this in just one moment, through changes in DNA methylation and acetylation, and the acetylated DNA is more vulnerable to the effects of stereotactic radiation. Okay, that was a mouthful, and that sounded like a bunch of gibberish, but I promise I'm going to explain that in just one second here. So, if you think about, okay, so the way I explained that radiation works, you're going to send this radiation through, it's going to put stress on the cancer and kill it. So, if you pictured, like the chromatin and the DNA is like closed off, so it's like protected, it's like in a shell. This is totally theoretical, just trying to come up with a way to visualize this. And then whenever you introduce an HDAC inhibitor, which is actually what beta-hydroxybutyrate is, we'll touch on that next, it causes it to open up, and now it's vulnerable to radiation. So using an HDAC inhibitor actually seems to make radiation more effective, because it causes that the acetylated DNA, it like loses its protective shield, and now it's vulnerable to being destroyed by radiation. And I know that explanation of mine is going to get ripped apart by the science nerds out there, but I think that that's actually a decent way to visualize it. If you can give me a better analogy for it, I'll be happy to use your analogy. I'll even give you credit for it. But that's the easiest analogy I can come up with when trying to explain this in layman's terms. Basically, the DNA is like this, and it's solidified, nothing can get through, and then boom, now it's open and things can pass through and kill the cancer. That's the best thing I can come up with on the fly, because I did not think that one through. So, the last thing to touch on, though, to wrap that whole line of thought together, is beta-hydroxybutyrate. So, beta-hydroxybutyrate is something that you produce when your body's in ketosis. And so you produce acetoacetate, you produce beta-hydroxybutyrate, and you actually produce acetone. And those are the things that your body produces when you are in ketosis. And that actually has nothing to do even with the ketogenic diet. You could just simply fast. If you're fasting, your BHB level goes up, which then I think the researcher, forgive me, Sachin Panda, I think that's how you pronounce his name, did a few studies where they had people fast before chemotherapy, which that logically would work very similar to radiation. So people are fasting, their beta-hydroxybutyrate level goes up. Beta-hydroxybutyrate, as I said, works as a histone deacetylase inhibitor, and chemotherapy, depending on which chemotherapy drug they used, and I can't recall because my memory's not that fantastic, but let's just say that they used a platinum-based chemotherapy drug. That works by increasing the ROS, so you're creating oxidative stress, and so then that makes the DNA more vulnerable to being destroyed, and that's why that would work. So this is this is at 15 minutes now, and the reality is I've barely touched on anything, but at the same time I feel like I've given you like almost too much information at once. So I'm going to stop myself there actually. But the point that I want to make is that the ketogenic diet is certainly not a cure for cancer. No way, shape, or form is it the cure for cancer. But it might be something that in the future research will show that ketogenic diets could be beneficial whenever you combine them with other therapies. So what I mean to say is that at this current time, the research does not seem to be very strong in favor of ketogenic diets as a treatment for cancer. However, it is conceivable that in the future you might combine chemotherapy with a ketogenic diet or stereotactic radiation with a ketogenic diet. There's even other really fancy drugs out there, and where you have immunotherapy and all kinds of really incredible new discoveries being made all the time. A lot of them are experimental. There's all types of different inhibitors and things like that. But basically, the idea that I'm trying to convey is that there's the possibility that maybe sometime in the future we'll find out that ketogenic diets work when used in combination with another therapy. So alone, there doesn't seem to be a lot of evidence for them alone, but in combination with other things, there is potential that they could be greatly valuable and useful. So if you guys have like specific comments, like very specific questions, post below and I will do my absolute best to try to answer them. But I do plan to make more videos covering this topic. So I will do my best to get into more details and talk about other cancer therapies out there, as well as covering more of the research that has been done on ketogenic diets and health in general. I want to talk about like brain metabolism following traumatic brain injuries. That's something I want to get into a little bit because I think it's really important that people understand that post-concussion there are things you can do to reduce your symptoms and actually help yourself to recover faster. But also, I want to talk about things with cancer too, because it's interesting. You look at lung cancer and it makes the PET light up, which would make you think that it's just drawing all this glucose into the tumor, and yet ketogenic diets don't seem to have a whole lot of benefit even in that regard. And then, gliomas are really complex, and they can even use fat as a fuel, which then just completely shoots the whole idea of a ketogenic diet. The glioma cells actually change and use lipids for energy. So much for your high-fat diet. So there's certainly certain cancers where it would have no efficacy at all. But that's something for another video, and I know I tend to talk for way too long. So I'm going to stop there, but if you guys have questions, please post them below, and if I don't address your question by responding to you with a comment, it's probably because I thought it was a good question and I plan to cover it in a later video. So thanks for listening. I hope that this was easier to understand than a lot of the science lecture stuff out there. Even I struggle to follow some of these doctors. It's almost like they're vomiting alphabet soup with all their AMPK, mTOR, AKT, and HDAC, and they never explain what any of those things mean. And And so, you have to like really follow closely, because if you miss anything, it's like, oh, well, doesn't everybody know what AKT means? And don't you know all the pathways? Well, no, most people don't. Had to look them up myself, so I had to learn them. In fact, I don't think I even learned them in my undergrad. I had to learn them later on. So, anyways, that's it.